Hi, today I'm going to explain Euler method using hand-drawn diagram. So first we draw the x and y axis, and then we start the initial point of x0, y0, where y0 is equals to 1, x0 is equal to 0, and this will be our starting point. So Euler method uses the formula of yn plus 1 is equals to yn plus h times f xn yn. Yn plus 1 is the next value of y we want to find, and then yn is the current value of y, h is the step size, how much we want to move at the x-axis, and then f, x, and yn is to find the slope of x and yn, given the differential equation of dy dx, x squared plus 1 divided by y. So, for example, let's use 0.1 for our step size. We calculate the slope at initial point of x0, y0. So, we use the differential equation of x squared plus 1 divided by y. So we sub in the value of x and y, which is 0 squared plus 1 divided by 1. And the answer is 1. So the slope will be 1. So next, we use the Euler method to calculate the next value of y, which is y1. So y1 is equals to y0 plus h times f x0 y0. The answer will be 1.1. y1 is equals to 1.1. So our next plot, x1, y1. So x1 is the step size 0.1, and then y1 is the new value, which is 1.1. So we plot it like this. So we repeat this process for each step, calculating the slope and also finding the next point until we reach the desired value of x.
Now I show you in Excel how I apply the Euler method to solve the IVP dy dx is equals to x squared plus 1 divided by y when y0 is equals to 1. So first I choose the step size of h is equals to 0.1 and calculate the approximate value of y1. So I use 3 columns. First column is the x value. So I start with 0 in cell F9 and then in cell F10 I type in cell F9 plus 0.1. So this is to increase x by 0.1 at each step. So I drag it down until y is equals to 1, x is equals to 1, sorry. And then the next column, which is the y value, is to estimate the value using the Euler method. I entered the initial value 1 since y0 is equals to 1. And then in cell G10, I type in the Euler method. So G9 is the previous value of y plus 0.1, the step size, times h9, which is the previous slope. And then the next column, which is the slope, is based on the differential equation of fx y is equals to x squared plus 1 divided by y. So in this cell, I type in the cell f9 to the power of 2 plus 1 divided by g9. And then finally, I fill in the columns here. So after reaching x is equals to 1, the final value for the y is y1 is equals to 0.911. So that is the Euler method result. Now let's find the exact value of y1 in the same IVP via general solution and compare it with the Euler method result to find the error. So we previously solved IVP using the general solution of dy dx is equals to x squared plus 1 divided by y when y0 is equals to 1. So after separating the variables and sub in x is equals to 1, y is equals to square root of 2 times 1 cubed divided by 3 plus 2 times 1 plus 1, and the answer is 1.914. And then for the Euler method, the answer is 1.9113. So to calculate the error, we take IVP value minus the Euler value. So it gives us 0.003. So the approximation is quite close to the IVP value. So this shows that the Euler method can give a quite accurate result.